Okay, Rahul. So I think we can give it a start on your presentation. So first of all, thanks for being here. To participate in the BSides Barcelona. It's always good, to see presentations around AppSec. So yeah, the floor is yours. All the best.
Thank you so much. Thanks for having me here. It's the first time in BSides Barcelona, and I'm glad that I can be part of this presentation this time. So welcome everybody to who is listening online live now or later on at a live stream recording to the presentation, the Clutter that's choking AppSec. Before we get started, a little bit about myself. My name is Rahul. I'm one of the co-founders at B45. We are an application security company, essentially kind of helping product teams across the world in terms of implementing and scaling application security programs. Personally, things that keep me at night, keep me excited in the AppSec world are things around application security automation, more recently threat modeling and the way threat modeling kind of seamlessly integrates with security testing and other aspects. Also a lot in terms of vulnerability correlation, vulnerability management, things like that. So for all the enthusiasts who share a common interest in any of these things that you see on screen, happy to connect offline and happy to chat more of these topics. So a little bit about this presentation. So I made this presentation first I started working on this presentation way back in November 2019. And ever since I've presented this in at least 15 different venues across the world. And every time I make this presentation, the impact that it has on people are very different. When I made this the first time around in person, I used to obviously kind of get a lot of feedback in terms of people who had multiple questions and people who could really kind of associate it with it differently. But since we're doing this virtually the last 2 years or so, things have been a little different, but yet, for those who are on the program right now, so my intention here is that even if you're in any part of product engineering, be it you're a developer, you're an architect, you're a DevOps engineer, you're a security engineer, my hope and aspiration is that there's something in this presentation that you can personally kind of take back from an implementation perspective. So having said that, let's get started. So I want to kind of start off really having a look at how product engineering has kind of moved on or has evolved over the last couple of years. And some of these things are not something that's really brainstormingly new or something like that, but still there are some very interesting developments that have happened. Obviously, teams are moving a lot more in terms of agile than waterfall, and I always joke that there's always going to be a group that is agile fall, which is between waterfall and agile. And we're also seeing a lot of accelerated deployments in terms of fabrics that are enabling teams to take applications to the cloud, especially with the advent of DevOps. So I'm talking about things like both on the CI front and on the CD front. So we're talking about more GitHub Actions-based integrations of the CI perspective, and you're also seeing a lot more catalysts helping continuous deployments, like things like Chef and Puppet and Ansible that are being more seen in terms of continuous deployments. In terms of sheer the architecture of apps itself is that obviously we're not looking at a lot of monolith apps anymore. We're seeing a lot of more of multi-tiered approach to application architecture, which includes a lot of microservices and serverless stacks that we're seeing as opposed to really large chunks of apps that we used to see a couple of years ago. And then we've also seen an increase in terms of third-party libraries, and that's quite evident with the advent of more SCA platforms that have become very relevant over the last couple of years as well. So all this from a testing perspective has also led to a more automation when it comes to not just functional and performance, but actually I see from a security perspective as well, there's a lot more in terms of testing and automation that we've seen. In terms of just the application delivery landscape, we actually see two distinct kind of ecosystems. So I typically consider, I usually, when I make these presentations in the US, I usually compare it to the West and the East Coast of the US, right? For example, let's take a typical Silicon Valley company in the Bay Area, somebody who's 200 employees, somebody who's working on a product. They have multiple deployments in a particular day. They probably have lesser number of applications. They probably working on 4, 5, or 10 core applications, but you see continuous changes having to those 10 applications. So you're seeing multiple deployments in a day and therefore multiple deliveries in a day. So that's one view of the world. Now, consider a large enterprise, let's say a bank or a financial institution or a large retail organization. They might have hundreds of apps. They might probably even have 500 apps, but those apps don't necessarily undergo the same kind of deployments as the other example that we saw. So you're probably looking at 1 or 2 deployments in a quarter or something like that. So even if you consider both these views of the world, one thing that's common is that the number of deliveries are more. For example, here you have 10 applications with a daily delivery, but there you have 500 applications with probably 1 delivery a month. So either way, the application delivery model has really moved very further. And this, we're talking about it at a time period now, but when I remember when Amazon moved to AWS a long time ago, they used to develop and deploy applications once every 11.7 seconds. And I'm sure that's something that's gone further as we speak right now. There's a third kind of groups that fall in between both these views, right? So there are usually companies who are product companies who actually say that they probably have like 100, 150 applications in their portfolio. And with the advent of DevOps and with the advent of application security automation, they actually are in both of these worlds, right? So they have massive releases, and with these massive releases comes a lot of challenges. Now, obviously, this is an image that a lot of us are familiar with many conferences. This is obviously the Gartner's infinite loop of DevOps and DevSecOps. Now, I'm not really sure about the rest of the folks here in the call, but me personally, and this is not even a V45 opinion, this is a personal Rahul's opinion, is that I find this image to be really, really confusing, and I don't think it really is as relevant to the current way in which we see application security automation and DevSecOps. So what I've done is I've kind of tried to give a different representation of what DevOps and DevSecOps really mean. And this is what I would call the true DevSecOps or DevOps model. So what you see on the top of this image are the typical application product engineering process, right? You essentially plan, code, build, test, release, deploy, operate, and monitor. And what you see on the bottom are the typical phases of security engineering. So what you see on the top is product engineering. What you see on the bottom is security engineering, which essentially is threat modeling, SAT analysis, DAS analysis, infrastructure as code, and finally security monitoring and attack detection. Now, what I'd like to do is I'd like to really kind of give a color code of where we see the security engineering process to kind of fit with the appropriate product engineering process. For example, threat modeling usually started off as an activity that was performed in the plan phase, in the place where people would probably do a design or an architecture review. Architects would really come up and say, let's look at the blueprints, let's look at and see what the application is doing, what are the various components that are being used, who are the threat actors, what are the kind of external or internal dependencies that we have, and so on and so forth. So that used to be threat modeling purely in the plan phase. But as they keep moving with security as a code, we are now at a space where you could do threat modeling as code. And that's a different presentation that I do. I would love to talk about that another day. But with the advent of things like threat modeling as code and taking threat modeling more towards the developers community, we're actually seeing threat modeling moving from the plan phase, moving to a little bit into the code phase as well. That's the reason you see a little bit of orange in that code diagram. SAT and DAS predominantly across code, build, and test. So therefore, you see that completely taking over to test, and so on and so forth. I don't want to go through the entire image here, but I'm sure you get the idea in terms of how the security engineering process is kind of finding its right way in terms of the product engineering process. And the reason I like this particular diagrammatic representation is the fact that every time I do a presentation, the color code changes, because at that point in time, in 2020, this color code looked really different. And therefore, the whole shift left model was very different than in 2021, where you have a lot more advancements and a lot more experiments that have been done in terms of taking code closer to security engineering and product engineering. So therefore, you see the fact that a lot of these color codes will keep changing as the years move by, depending upon the kind of advancements that we make. So therefore, with the current state, the DevOps and the DevSecOps movement has really picked up, right? So businesses across the plane want to move faster, they want to go to market faster, and therefore DevSecOps, amongst other things on the screen that you see here, has led to a lot more in terms of tooling. It's seen an increase in CI tooling, it's seen an increase in test management, build management, deploys, post-deploys, and so on and so forth. And therefore, security too has kind of moved from what we used to call it as a gatekeeper function, today much more relevant and being able to kind of embed itself in terms of different parts within the product engineering landscape. And people talk about the security champions program, which really is that. It's the hub and spoke model where you have a centralized security team and it has satellite squads of the central security team who kind of embed themselves with the various members of the agile team. But all this means that we're kind of using more tools than what we were using when security was a siloed activity. And this also means that there are a lot more integrations between tools and also between one unit and another. And these are some reports from the 2016-2017 year. I intentionally kept that quite dated because I wanted to see the contrast, right? For example, if you look at here, like mature DevSecOps shop run almost 300 scans a year, and this was way back in 2017. And back then, you had 3,000 vulnerabilities that were disclosed. But if you look at the kind of time that it takes for people to kind of fix those issues, it's on an average, it's 34 days. And that's really the problem, because the more number of vulnerabilities that you find, it's going to overwhelm the system in terms of being able to take corrective actions to fix those vulnerabilities. And that's a problem statement that I just want to leave it there for a moment. I'll come back to this a little later, but I just wanted to kind of give you some context in terms of the downside of potentially kind of increasing tooling and just focusing our attention a lot in terms of just finding issues as much as it is about fixing those issues. And in terms of diversity and scale, also, we've kind of really kind of seen a lot more change. Today, we're testing servers, we're testing containers, we're testing applications, we're testing API services, databases, orchestration services, cloud services, and then you have third-party libraries. And all of this really means that with more tools, there is a lot in terms of information overload that security engineers are having to deal with, right? It is not like the days old where you just had one app and you probably had 4 or 5 components and you should test those components. Right now, with the architecture kind of changing as much and with so many testing being done, there's really a lot more that you need to kind of assess and therefore look at. And therefore, with that information overload, we have some challenges. We look at some of them in more detail, but application security teams themselves have some serious constraints in terms of availability, right? In terms of time that they spend, in terms of triaging issues, sorting issues, and so on and so forth. And there are constraints in terms of tools, which we'll see further as well. There are some major inconsistencies in terms of the results that some of these tools give. And a lot of us in security engineering still don't know how best we can integrate ourselves in terms of engineering workflows. So there's a big gap in terms of security engineering and product engineering in terms of a technological integration. And finally, you have an issue in terms of managing vulnerabilities and remediating vulnerabilities themselves. In terms of the one of the biggest issues to consider to be bandwidth, right, within the application security team. That's quite evident in terms of the number of job posts that we see on a daily basis of people calling application security engineers to come and join their team. And even today, with businesses moving agile, they're hiring more devs, they're hiring more agile project managers, more ops folks, more cloud engineers, but no one almost from a exclusive security standpoint. And something that we've noticed in a lot of forums like these is, I mean, not just here, but let's say even if you're doing meetup groups and things like that, people really have a lot of job openings for application security engineers, which is great. But then the reality is that when they actually go and start working, their expectations and what they're supposed to be working on are quite different. And just to talk about that, I just wanted to take an example of a small story here in terms of how a typical security engineer's time is spent. So let's say, for example, this is someone called Jason, and just obviously a fictitious person. Let's say that he's joined this new digital product company, let's say in the banking space as a security engineer, and let's consider what an application security a day in a typical week would be like a couple of months down the road. So a couple of months down the road, this Jason is asked to take care of security assessments, which is okay. Then you're supposed to kind of help your developers remediate those findings, which is fine. But since you're in the banking and industry, sometimes you get called on to the CISO and you're kind of asked to help in terms of compliance audits from the security perspective. You're also involved in drafting security reports. Then you're asked to onboard tools. You're doing threat modeling. You're automating tools in CI/CD, validating those fixings, reviewing those fixings, and you're doing so many things almost with no time that you have to focus on your core domain, which is that of security research. And with all of these things in place, we still asked and we're still told that we need to continuously test for security, right? And now Jason, the tester, is not happy. So he's not the same Jason that we saw earlier, right? Because now he's pissed off. And that's really what happens when this new world of application security, with all of this automation and things like that coming into perspective, it kind of changes the actual reason or the actual core objective of a security engineer or an AppSec engineer, right? And for today, we're not going to be looking at all of these things, right? We're essentially going to be looking at one major issue, which really is that of managing vulnerabilities. You want to kind of, and that really is the crux of my talk, which is the clutter. And the clutter in application security, which is that of managing vulnerabilities. And I often say that an application security program is only as efficient as managing the vulnerabilities that come out of it. And I mean, what really is the point of having all these amazing tools and platforms and teams and processes if software vulnerabilities cannot be efficiently generated, they can't be categorized, they can't be shared, they can't be remediated, or even worse, finally prevented from getting back upstream and accordingly managed, right? And this clutter is probably the most significant reasons that prevent product and security teams in not being able to bridge that proverbial gap between the ideal and the practical of DevSecOps, right? And being able to kind of increase what we like to call the secure product throughput. So let's dig a little further into this clutter. But before we do that, it's essential that we understand what really is the anatomy of a vulnerability. What do we mean by a vulnerability, right? But even before that, I know that this is a BSides forum. I know there are a lot of accomplished engineers here. A lot of us have been in the security world for a while, but trust me, it is really important that we understand the difference between these three concepts, because the number of times that I've had people confuse these three things, these three concepts, is quite significant. So before we start looking at what the CWE, what the vulnerabilities are, let's take a look at what CWE, CVE, and CVSS are, because I think this is very important for us to kind of move further. And I often take an example that these three things are something like the Walden brothers, right? We all know that they're important, but you don't know who is what Walden, especially if you remove Alec Walden from the equation. So with these remaining three brothers, you really don't know who's what, right? So let's do a quick 101 in terms of these three concepts. So the CWE is the common weakness enumeration, right? And this really is a system for categorizing software vulnerabilities. It has over 600 categories, including specific categories for buffer overflows, path directory traversals, race conditions, cross-site scripting, hard-coded passwords, insecure random numbers, and so on and so forth. So every time you find a vulnerability, that vulnerability will be categorized under a particular bucket, and that bucket is the CWE. Now, the CVSS, which essentially is the common vulnerability scoring system, that is really a way for you to categorize the severity of a vulnerability, right? It is a free and open source, open industry standard, which kind of helps you assess the severity of a computer, of a security vulnerability. And CVSS really kind of attempts to kind of assign severity scores to each of these vulnerabilities, right? So that you can understand which needs to be remediated first, which needs to be prioritized first, which needs to be prioritized second, and etc. So that's the CVSS. And the CVE is the common vulnerabilities and exposures, which really is a dictionary type list of standardized vulnerabilities and things like that. So every time there's a new zero-day attack that an entry in the CVE, and then it would find an entry potentially once if it is a web application attack, it would essentially usually find a space in the CVE under one of those categories as well. So this is really what the CWE and the CVSS and the CVE mean. And like I told you, this understanding is really important for some of the next slides that we're going to look at. So we talked about the issue of tools, right? Tools are great. We've got a lot of tools in application security these days. They're great. They make our lives easy. They're able to find flaws in ways and approaches and generate the data required to find these things that manual testing might not be. But there are some inconsistencies. A lot of them, both open source and commercial, have a lot of inconsistencies in the in the way that they produce the data. For example, two tools could provide the same vulnerability but different names. They call it differently. They have different verbiages. Most tools kind of correlate these results based on the CWE, but a lot of tools don't even give you CWEs. Example, open source tools like Bandit and Brakeman. These are tools that don't give you results that have a CWE number there. So how do you kind of correlate this information? There's no way for you to kind of backtrack the vulnerabilities from these tools and give them a nomenclature. And some of them don't even give you the taxonomy. For example, you don't know whether a particular issue relates to an OAuth vulnerability, relates to a SANS-Top 25 vulnerability. There's no kind of taxonomy to these vulnerabilities as well. And let's see some examples. So let's say, for example, that you're running a SAS, an SCA, and a DAS. And let's say that you find something like a SQL injection. Now, there's a good possibility that each of these type of tools would call SQL injection in 3 different ways. For example, a ZAP or a burp might call it a blind SQL injection. A SAS might call it a time-based SQL injection. And then you would probably have other kind of massive inconsistencies. Because believe me when I say this, we've literally tried doing this for almost a year when we are building our own intelligent correlation system, which is Orchestron. And we've tried really every combination in the book, right? We've tried string matches, we've tried Levenshtein distance algorithms, we've tried ML algorithms, and all of these provide a lot of these inconsistencies. And what's worse is within web application scanners, let's say you put an infrastructure or a network security scanner like a Nessus or something like that. Now, Nessus will give you CVEs. They don't even give you CWEs. And then web application security tools will give you CWEs. And how do you correlate between a CWE and a CVE? It's not going to make sense at all. And let's see how some of these actually pan out. Now, this is the result between Acunetics and Checkmarx. The one on the top is Acunetics, and the one on the bottom is a result from Checkmarx. This is obviously from a intentionally vulnerable app, so don't worry if you see some code on the screen. Now, I just want to focus your attention to CWE79. Both these tools have found the same issue. CWE79 is called by Acunetics as vulnerable JavaScript library, but in Checkmarx, the same line of code, the same CWE is being called as reflected cross-site scripting. So the same line of code, same CWE, but called differently by 2 different tools. This is CWE 693. The result on the top is AppScan, and the result on the bottom is our standard good old friend burp. Now, AppScan calls this vulnerability insecure cross-frame scripting, and burp calls in protection mechanism failure. Now, imagine you give this result to a developer, ask them to fix it. They would look at this vulnerability in 2 different tools, and they would have nothing to say that they are the same issue. They would think that both of these are 2 different issues. Let's find another example now between 2 SaaS platforms. The one on the top is FindSecBugs, which is an open source platform, and the one on the bottom is Veracode. Right? We're talking about a CWE89. It's called SQL injection. It's a SQL injection vulnerability, but look at what they call. I mean, FindSecBugs calls it non-constant string pass to execute, blah, blah, blah. And then Veracode calls it neutralization of special elements using SQL command. Right? And finally, we have an example where you don't even get a CWE. Right? This is from Node.js on the top and Zap on the bottom. Zap tells you that it's a SQL injection vulnerability, gives you that CWE89, which all of us know. But Node.js doesn't tell you anything. It doesn't even tell you what that vulnerability is. So how would a security engineer or how would a developer, especially when you use so many tools in automation, how do you try and get that centralized view of a vulnerability? That's really the problem that we're kind of dealing with. And the worst is when you run this in scale. Let's say have a nightly build or a daily build, and let's say that this is a very simple kind of an architecture. You just done a git pull and you have a bandit, an SCA, a zap, and a burp. But this is a very simplistic view of the world. Usually, you would have a much more complicated kind of a Jenkins pipe, and then let's say you're doing daily builds or nightly builds, and the kind of data that would get generated is just phenomenal. And imagine you have to go through the data on a daily basis just to kind of find out what those issues are. It's not a simple task, right? Let's also talk about some contributors that make this even more difficult. First is the issue of false positives, right? You cannot eliminate a false positive, and that's something that I want to talk about, or at least I want to stress. I mean, if somebody's saying that they can eliminate false positives in application security, you can't. All that you can do is you can reduce the effect of false positives, right? And therefore, if there's a way for you to kind of declutter the results by showing false positives separately, that itself makes a lot of score. For example, burp gives you something called a scanner confidence index. I don't know whether other tools give it, but I know for a fact that burp gives it. Every time you find an issue in burp, next to the issue, it will give you a confidence index. So based on the confidence index, you will know how impactful or how true that particular vulnerability is. So false positives is a big issue. The second issue is in terms of prioritization or severity, right? Different tools give you different prioritizations in terms of how severe a particular vulnerability is. And especially, you need to look at severity in context to your application in your particular organization. So because I can't take two applications and call SQL injection on both these applications in the same priority. In one place it could be a critical, in another place it could probably be medium, depending upon what the impact of that vulnerability is. And finally, it's the issue of remediation strategy, right? In terms of how do you remediate that vulnerability. Most tools will give you very standard cookie cutter approaches to remediating vulnerabilities, but again, we all know that doesn't work quite well because developers need to really kind of have more than one option to find and to fix those issues. It doesn't make sense if you just give them. Sometimes remediations could be incorrect, or sometimes remediation strategies could be insufficient, which means that you need to give them an alternative view or an alternative idea in terms of remediating the vulnerability. So that could also be an issue that comes across. So with all these said, we've talked about problems all this while. Now let's talk about a solution to this. How do we potentially declutter this? Now, obviously, there's no magic pill approach, just like I say with everything else in AppSec. Application security is not a one-size-fits-all. So therefore, the solutions to application security is not also a one-size-fits-all. It really depends on the context. But I do have some ideas that I want to float around the room and see which of these things work. Right? The first thing is simply the issue of us being able to do two things very clearly: find bugs early and fix bugs early. This is really the motto, or this is the mantra that security engineering teams would need to follow for a more well-washed or well-oiled machinery for security. If we can kind of focus our attention towards just anything that we do in security engineering, it needs to fall under one of these two buckets. It either helps security engineers find bugs early, or it helps developers fix those bugs early, right? If you can kind of have this outlook, it will kind of help us in terms of what we're talking about. I'm sorry. The first thing that I want to talk about is vulnerability correlation, or more so automated correlation. Now, going back to a previous discussion, let's say that you have a string of tools in CI that runs on a nightly basis, right? Which means to say that every night you're going to get results across all of these tools. Now, correlation platforms essentially kind of help security engineers triage issues without them personally needing to say, okay, so here's an issue from Zap. This says it's a SQLi. I have something else from Zap. It seems like a SQLi. I want to put these both together in the same bucket. So correlation tools do that. They are able to identify results that come from multiple tools, and they're able to kind of correlate those results. And there are some examples of tools. I'm not going to name those tools here because this is I don't want to make it sound like this is commercial, but you can actually go ahead and look at a lot of open source and commercial tools that are out there that helps you correlate those vulnerabilities, right? And because if you remember the previous slide that we saw as to how different tools provide different formats, right? For example, let's say you have a source composition analysis run finding a particular tool. they're widely different in the way that the SaaS would find that issue. For example, an SEA would say that it found a particular issue in the nested dependency in a library 3 levels down. For example, say an encryption library that uses, say, a triple def has a particular issue with the base64 implementation in that library and something like that. So that would be the world of the view that an SCA would give. But a SaaS would give you a completely different view of the world, give you a line number where an issue exists. So compilation tools essentially kind of helps you put these various data sources together in terms of being able to take a call. The other thing I want to talk about is security as a code. Now, we've always talked about the fact in all security conferences and talks, we've always said developers need to understand security, and this is something that we've been talking about in the last 10 years in application security. Now, I want to change this statement. We've talked enough about the fact that developers need to understand security, but I think we need to now ask security teams to understand code. And that's the fundamental change that needs to come about. Yes, developers have been trained to understand security, they've done security courses, they've done all of these things, but how many security engineers actually understand code? How many of them still write code or read code at a fundamental level, right? Because if security is able to understand code, a lot of these problems get solved. For example, they can write exploit scripts, and exploit scripts actually help you take a particular security business logic flaw in an application security flaw, and then be able to kind of write a Selenium script around it or a Cucumber script around it and add it back to a security regression. That is possible, which means that just like how functional testing has functional testing suites, security testing can also have security testing suites. And that's a possibility if you're able to kind of write code. You're also able to give very, very focused remediations or alternative remediations to your team. Therefore, being able to, be more empathetic towards developers, be able to kind of talk to them in the same language as they do, and therefore you're able to kind of get into that community a little bit as well. So that's another advantage of having to code. The third thing that I want to talk about is that of cross-training, right? And what I mean by cross-training is the fact that we talk about security and engineering being in two different silos and things like that. We are doing a lot of work in terms of bridging that gap from a technology perspective. I think there's also a lot of bridging that needs to be done from a cultural standpoint. And part of that is being able to kind of train. So when we talk about training, I just don't mean training as a point-in-time activity. Especially in terms of product teams, you have a lot of people. Let's say that there are a typical product team would have a developer group, they would have a QA group, they would have a automation or a DevOps group, and they would have a security group. Now, there is a lot of skills that are transferable amongst these people. So there's a lot that security can learn from QA. There's a lot that DevOps can learn from development. There's a lot that QA can learn from security. So there is a lot of need for cross-functional training. And this training would kind of help build a lot of efficiencies within the existing client organization itself. So you are able to kind of not just look at vendors for all things, but you're also being able to develop internal capabilities for us to tackle a lot of application security problems. And that's something that we've been talking about for a lot. So training should be more of a reference material, right? And not a curriculum. It should be like what doctors or attorneys do. Even today, you go to a doctor, you go to an attorney, they would go ahead and refer to case files. They would go ahead and refer to previous such instances that have happened. So training needs to be like that. Training program needs to be something that developers or product engineers are able to refer to, and not something that they just get certified against, or just something like something that they need to do, right? So I often say, know what you need and not what you need to know, right? So it's always important that you need to have some skill at a point in time that is relevant to the kind of work that you're doing, not something that you just accumulate over a period of time. I've also seen a security champions program be very effective, and we talked about that a little earlier as well, where you said that you could have a centralized security team and you could create these squads of security champions who are essentially developers turned security professionals who are able to kind of take the message of security programs across to various teams. So therefore, you're not having to kind of have the entire burden of security of an AppSec program on a few security people, but you're actually being able to kind of have them split across. So these are some of the things that we could do from a training initiative. I know we've got another 10 more minutes. I want to just keep some time for Q&A. But in summary, I'd like to leave you with this thought, right? From a core vulnerability management standpoint, I think the focus should be beyond just traffic light indicators of how many vulnerabilities are high, medium, or low, or just the sheer number of issues that the teams have found. Because there is an actual value in the metadata that these vulnerability statistics provide. For example, if I see more issues propping up in a certain class of vulnerabilities that are more design-oriented, for example, perhaps the focus needs to be around threat modeling and not so much around investing in static code tools. And it is also about using the right set of tools. Organizations would need to kind of look at procuring platforms that not just keep costs in mind, but things like allied benefits, such as how well do they integrate with my other tools, or how well do I integrate with my existing workflows, and what kind of quality of metrics do they give, right? And things like that. Now, while this slide summarizes what we've discussed in a nutshell, the larger role that we as a security community have to play in this decade, and I always say that the last decade, the end that in 2020, was a decade that kind of gave application security the prime time slot in product engineering, which is great, because today when you say AppSec, people stand up and people look at you, people have to know what you have to say. So that is done. The last decade gave AppSec the spot. But going forward, I think the focus for us really needs to be being able to make the best use of it, right? So while this decade was actually about realizing the various possibilities that automation and the scale of AppSec could bring to product engineering. So I think that really needs to be the focus for us as security engineers as we move forward. So with that, I'd like to say thank you to the BSides Barcelona team for inviting me and accepting me for this presentation. So with that, having said that, I'd be happy to take any questions that anybody might have.
Thank you, Rahul. It was a very interesting presentation on this new paradigm. Is there any question? I don't see any question in the Zoom.
Let's check also Slack. I think there isn't anything specific. So first of all, Rahul, thanks for your presentation. That was very interesting. So I got a question actually. So, I mean, we're seeing that security teams, in some of the cases, let's say a little bit overloaded, when we're talking about, vulnerabilities, right? Like we count them by the numbers. So I wonder if you have maybe some ideas or concepts about maybe prioritizing in a different way. So I've seen teams that they start moving more into, trying to analyze the risk to the organization versus, to the specific, let's say, vulnerability risk score, that might not be, exactly the same. So I wonder if you have any ideas or thoughts, about, that prioritization of vulnerabilities to be more, let's say, pragmatic, in the way that we do.
Yeah, so I think the idea here really in terms of the role that a security engineer plays as well, right? And that's really, I wanted to kind of think about that in terms of the presentation as well. So I think the way the role description of an application security is defined today is quite confusing, because people always think of an AppSec engineer as almost like a superhero. He needs to understand cloud security, he needs to understand web application security, he needs to understand threat modeling, he needs to understand internet security. So it's not going to be possible. So I think the focus of the presentation also was to say that try and understand what skills are core for an application security engineer. So therefore, you give him or her enough time and enough space for more research and more, things that can be more intuitive, and in your words, trying to be more pragmatic. Because today the problem really is that people are overwhelmed and overloaded with work that are not really core AppSec work. A lot of things that could be automated are not automated, and a lot of things that should not be automated is what is automated. So I think there needs to be a step back, and we need to kind of think about what are the core skills of an AppSec engineer, and therefore look at it from that viewpoint.
Brilliant. That makes sense, Rahul.
Rahul, I have a question for you. Do you think
Sure.
if an organization is mature enough, a bug bounty program can help with the overload of information that the security teams have? What's your point of view on a bug bounty program?
So I think a bug bounty program is very, very useful. I think it is one of, if done correctly, it is a great source of additional vulnerabilities that a program management can get, because today you have different source of getting issues. You get issues from tools, you get issues from internal pen testers, you get issues from your customers. Now, a bug bounty program is just a way for you to get any kind of issues that all these sources have missed from an external party, because a pen tester is a pen tester, whether it is internal or external. So I have seen organizations where they run bug bounty programs to get a very valuable source of information for potential security issues that neither tools have found, or internal pen testers have found, or external pen testers have found. So therefore, sometimes bug hunters might find that just one or two very specific or critical issues, which could be great. And once you find those issues, you also have an opportunity for you to kind of take those issues and loop them back into your pipeline for you to create threat models that mimic those issues. So more bug bounties also gives you an opportunity to create more innovative security test cases that you might not have thought of.
Brilliant, Rahul.
Thank you.
So thanks so much for your time today. I really appreciate it.
Thank you so much.
I hope to see you again in
future
future conferences.
Sure. Thank you so much. Thanks for having me.